We are here to try to finish up this exponents unit, and so I'm going to sort of combine the last 3 lessons into one because I think we can do that and be just fine. So today we're talking about how to write these rules, which we did last lesson, but this time there are going to be percents involved, and we're going to be focused on, how to know if something's linear or exponential. And so I want to talk first about percents and why percents mean that we're dealing with exponential growth. So if things grow by a percent, that is exponential growth. Okay, here's why. So I want you to imagine that you have $100 and it grows by 50%. Now you might think, well, that's linear because every year it's 50%, right? Plus 50%, plus 50%. But that's not the same thing as $50. 50% means you get what you had before plus half of it, right? And so if we have $100 now and we have 50% growth, that means we get $100 plus half of it, 50% of it, right? So that's $150. So that means that we gained $50 in the first year. Now, in the second year, we're not going to gain $50, and that's why it's not linear. We're actually going to gain more. And the reason is that we're starting now with $150, and we get to add half of that. And half of 150 is more than the $50 that we earned in the first year. It's $75. And so I think if I'm right, that's $225. So as your money grows and grows, the amount that you're adding every year also grows and grows. And that's why it's not linear, because we added 50, but then we added 75. So this is a 50% growth, 50% growth, but the actual value changes, and that's why it's exponential. So down here, this is just a quick review. So first we have linear functions here, and that's y equals mx plus b. Linear functions grow or decay by a constant amount, and that constant amount is the slope, okay? Now exponential functions is the new stuff, and you've been doing a great job with this. The equation is y equals a times r to the power of x, and r is the growth rate. A is the start value. That's down here in case you need to look back at it later. So if we're like, you get 4 times as many whatever, well then r is 4. Or if it's like you get half as much, well then r is a half. But if it's growing by a percent, then we have all of this down here that I'm going to go over. But it really resembles what we did up here. If something is growing by a percent, then you have to figure out what is the percent that increase, what's r. You always get 100% of what you started with, and so you're going to do 100 plus whatever the change is. Okay, so in this case my change was 50%, and so it's 100 plus 50, so that means your growth rate is actually 150% because you get 150% of what you got the year before. But then you have to divide by 100 just to convert it into a decimal. This just converts it into a decimal. If you have exponential decay, then you'll take your percent decrease and subtract that from 100 and then divide your result by 100 to convert it into a decimal. I know this is a little confusing, but we're just going to jump in with some examples. So example 1, in 1985, there were 285 cell phone subscribers in the small town of Centerville. The number of subscribers increased by 75% per year after 1985. So is this linear or exponential? Well, I hope it's easy for you to see that this is exponential, and that's because we're dealing with a percent increase. If it's a percent increase, it's always going to be exponential. So the equation, let's come back up here. The equation is a times r to the power of x. A is the start value. So there are a lot of numbers here, but a lot of them are the years, so don't get distracted by that. It says in 1985 there were 285 cell phone subscribers. That sounds like my start amount. So I'm going to come in here and type 285, and then I need my growth rate. Now my growth rate, I might come up here and try to work it out, but it is growing, it's increasing by 75%. So I'm going to come up here and maybe I'll use like a different color, or I'll see if I can highlight it. Oh, I'm just going to use red. Okay, so R equals 100. This is percent growth. plus 75% growth. So that's going to be 175. And then I have to divide that by 100. So if I come over here and I go to Desmos, and I'm going to click Scientific Calculator, and it'll show me the calculator. So I have 100% plus my 75% growth, and then I have to divide the result by 100. And so R in this case is going to be 1.75. So that's what goes in the parentheses, 1.75. And then you always make x be your exponent. And so because I'm in this equation editor, I hit Shift 6 to the power of x. So that's the equation. So this 1.75 means 175% of what they had the year before. So the question we're trying to answer is, how many cell phone subscribers were in Centerville in 1994? And so this is slightly tricky just because we're dealing with years. X in this case stands for years. This started in 1985 and it's asking me about 1994. So I have to quickly figure out how many years have gone by. So take a minute and see if you can figure out how you could calculate that. We just have to subtract. So 1994 minus 1985 to see how many years there are in between, and that's going to be 9 years. Whoops, whatever, 9 years. Okay, so to type this into our calculator, I'm going to take this, and I can even just copy and paste it here. So 285 times 1.75, but instead of the x, I'm going to put a 9 in here. So that's what I type into my calculator. I'm going to copy it again. I'm going to come back to my calculator, and I'm going to just paste that in. I do have to redo that exponent because it doesn't carry through. And that's my answer. It's talking about cell phone subscribers. That's people. So I think it makes sense to round this to the nearest whole number. So it's 43,871.9 people. That's awfully close to 43,872. And so I'm going to go ahead and type that in as my answer, but I'm going to change that to a 2. And the units are important here. So we're talking about cell phone subscribers. Okay, sweet. Okay, let's look at example 2. Example 2, Maricela invests $500 in Facebook stock. Over a period of 6 years, it loses about 4.2% annually. If you would like to try this problem on your own, I think that would be fabulous, and then you can come back and see if you did it right. So if you feel confident, pause the video, try it on your own. All right, so again, we have exponential here, and that's because there is a percent change. Or you could say percent decrease or something like that. The equation, so I start with the start value. The start value is $500. And then I have to think about what R is. So again, I'm going to come up here and I'm going to work this out in red. So R equals, I always start with 100. And then I have to add or subtract the percent change. In this case, we're losing money, and so I have to subtract 4.2. And then I divide my answer, whoops, my thing went backwards. Divide my answer by 100 just to convert that percent into a decimal. And so that's going to be my growth rate. So I can come back to Desmos. I'm just copying that, and I'm going to paste it here. And it's telling me that the growth rate is 0.958, and that makes sense. It should be less than 1 because we have decay here. So coming back, I put that number in here for my growth rate, and then Shift 6 to the power of x. So start with 500. Every year there's 0.958 times the amount of money that there was the year before, to the power of x, where x here is years. How much will her Facebook stock be worth at the end of the 6-year period? All I have to do is take this and replace the x with 6. This is super simple. And again, to figure out what that equals, I'm just coming over to Desmos. I'm typing that in, and I'm just fixing the exponent. And this is money, and so I think it makes sense to have dollars and cents here. So $386.51. And if I round, that 2 means the 1 will stay as it is. So I'm going to come back over here. There it is. I'm going to throw a dollar sign in front because we're talking about money, and we're done. One more example I want to do with you. This one says Ariana's mom gives her $100 and tells her that if she saves it without spending any, her mom will give her an additional $20 each week to add to her savings. Is this linear or exponential? So in this case, Ariana is getting $20 each week. That is a fixed amount. That is a constant rate of change. And so that means this is linear. And the reason you would say something like constant rate of change, plus 20, right, is the constant rate of change. So to write an equation for this situation, we're going to use y equals mx plus b, right? In this case, m is the slope, and the slope is the constant rate of change, which is positive 20. And so I'm going to put a 20 there. If it was going down, I would have used a negative number there. B is the start value, the y-intercept, and the start value here is the $100 that her mom gives her at the beginning. And then this last one, how much will she have after a year? Well, that's 52 weeks. X stands for weeks here because it's $20 each week. So all I have to do, same thing I was doing before, I grab that part of the equation and I have to just replace the x with 52. Now in this case we have to be careful. This is not an exponent, it's 20 times x, and so I have to make sure that however I type it, it looks like multiplication. And then to figure out what that equals, back to Desmos, 1140. Again, we're talking about money, and so we want to make sure, I'm just copying and pasting, that when we put it in here, we use a dollar sign, okay? 1140. So if you watched and didn't fill in the notes, great. If you did fill in the notes, great. It doesn't matter much to me. What does matter is that you do this independent practice on your own. There are 4 problems just like the ones we did, and then 1 problem where you're comparing a couple of things. And this one I really do want you to do on the actual worksheet. It'll just help me grade it a little bit faster, okay? And then as always, just let me know if you have any questions.